if you look at the factoring sheet, are there any of the factoring problems where you are brain farting and you do not remember how to factor them? So remember one. That's good. That's good. What type of problem is number 2? Yep. It's a slide divide. How can you tell it's a slide divide? Yeah, the number in front is not 1. It's got an actual number there. And the number in the front is not a GCF. So we're going to have to take the number in the front and multiply it by the -12. Today, having a calculator might be useful if you are rusty with some of your multiplying, dividing, that sort of thing. Okay, so 5 times -12 is -60. So we're looking for two numbers that multiply to -60 and add to 11. Do not say them out loud if you know. So if you're not sure what they are, you can do -60 divided by x. -60 divided by x. And then you can hit second graph. And there's all your options. So you're looking for numbers that multiply to -60 but add to 11, positive 11. What numbers would add to positive 11? So it should go this way. 15 and -4. Okay. So I've got p minus 4 and p plus 15, and I'm not done. That's not the answer. Yep. So I slid the number over, then I have to divide by the number that I slid by. So I slid a 5, so I need to divide by 5. Okay, what else do I need to do? Reduce the fractions if you can. So does 4 over 5 reduce? No. Does 15 over 5 reduce? Yes. What does it give you? 3. Okay, so I have p plus 3. And then once the fractions have been reduced, if they are still fractions, what do you do? Yeah. And you bottoms up, 5p minus 4. There's your answer. Okay. Is there another one we should look at? 15? Is 15 written in the correct order? No. So we'll go ahead and fix the order. Okay. What type of factoring is 15? GCF. Yeah, all it is GCF. It's nothing else. So between the 56 and the 63, what number could you divide out of both of those? M comes out of both of those, but what number? 7? 7 comes out of 63. Does 7 come out of 56? Does 7 come out of 56?
Yeah.
Yeah? Does 9 come out of both of them? I don't think 9 does. Okay, so 7 does. Okay. So we're going to take out a 7, and we're going to take out an M. Okay. So 56 divided by 7 is 8. And m to the 4th, if you divide out an m, what do you get? M to the 3rd. And then 63 divided by 7, 9. And since we took out an m, it's gone, and so we're done. And then whenever we do GCF, we always look at the parentheses to see if we could do anything else. So 8m to the third plus 9, is there anything else we could do there? 8m to the third makes me think maybe. What about the 9? No. Okay. 8m to the third, yeah, 8m to the third makes me think cubes. 9 does not. That makes me think squares. So, okay, so this one's done. Okay. All right, anything else on the sheet that's making you feel rusty? How do you guys feel about number 6 with that negative in the front? You guys feel fine about it? Okay. Yeah, so you take the negative, yeah, it's a GCF. And you always, if you have a negative in the front, you got to take the negative out. Can anybody find a difference of squares problem? Number 5, okay. Is number 5 only difference of squares, or does it have something else too? Does it have GCF? What's the GCF?
I was able to do GCF pretty easily.
Okay. What's the GCF? 4 and x squared. Okay, so we're going to take out a 4x squared. And then when you take out the 4x squared, what's left over? X squared minus 25. Okay. Is it still difference of squares, or did the GCF get rid of it being difference of squares? Still difference of squares, okay. So now, what do you do with the x squared minus 25? Square root each of the terms, and what do you get? And x plus 5. Okay, so we got 4x squared as the GCF, and then an x minus 5, and an x plus 5. Okay. Yeah, don't forget to rectangle your answers.
Don't forget to box your
That's what I was literally just thinking that. If you box your answer, it has to be 3D. 3D box your answers, yeah. Okay, are there any other problems you guys would like to do together? Anything else seem intimidating? Maybe the numbers are big, or maybe they're unkind. Yes. Yes. Yep, exactly right. Yeah. So the 2 and the p cubed are the GCF.
So for number 6, can you just take out 2 and cube? Minus 2 and cube?
Uh-huh.
Right.
So we have the 2p to the third. 6 divided by 2 is 3. P to the fifth, if you take out p to the third, that leaves you with the p squared. And then for the second term, you took out everything. So 2p to the third divided by 2p to the third is 1. You have to leave a 1 as a placeholder, not a 0. Leave a 1 as a placeholder, not a 0. That's a good question. And then the question that Alex had asked about number 6 was, do you take the negative out and then take negative 2 out and then take n to the third out? And the answer was yes. Yes, you do take out the negative. Should always be positive in the factor, yes. Okay, so I'm going to give you guys a little bit of time to keep working on this, get this finished up, and then once we finish the factoring, then we will get our notes finished up from last night and then proceed into simplifying rational expressions. Sound good? How did we feel about the notes last night? Did they make sense? A couple examples we did. Marvelous. All right. Okay. So if we look at example 5, and then we remember the steps, I've got them in front. I've got 2 sheets. So the first step is to write the problem as numerator over denominator, which is already the case. The second step is to write the terms in descending order, which is already the case. They're written in descending order. The third step is to factor the problem on the numerator and the denominator. So if we look at the numerator, what type of factoring do we have to do? Difference of squares. So x squared minus 16 would be difference of squares, and so what should the factors be? Perfect. So x plus 4, x minus 4. And then for the bottom, says factor out a -1 if the first term is negative. So we do need to factor the bottom even though it looks like the two terms have nothing in common because the first term has a negative. So we're going to factor out a -1 if the first term is negative, which it is. And when you factor out a -1, what do you have left over? A positive x and then a -4. Okay. So what do you guys see that can cancel? Yeah, we have the same factors, x minus 4 and x minus 4. So we are left with an x plus 4 on the top divided by a -1. Now, most people would not leave that in factored form. Most people would say, oh, I have an x plus 4 divided by a -1. I can actually do that division. So what is x plus 4 divided by a negative? Yeah, it's a -x and a -4, and that's what our final answer is. All right, brains feel good on that one? Okay. Next problem, number 6. So step 1 says make sure the problem is written as numerator over denominator. Is that the case? Yes. Step 2 says make sure the problem is written in the descending order. Is that the case? No. So what needs to be fixed? The top. The bottom is good, so we're going to leave that. X squared minus 2x minus 15, that is fine. How should the numerator be written? Okay. Okay. And then when I start the problem, I just start canceling willy-nilly, right? I just cancel the x squareds. Those can go away. No, we can't do that. That's actually going to kill puppies. I don't know if I mentioned that in the video, but those were the animals that we were protecting. Yeah, that's what a dying puppy sounds like. So this, if you start canceling, if you cancel before you factor, then you were trying to tell me that a subtraction problem and a division problem are opposites of each other and that they should cancel each other out. Which is not the case, right? Subtraction and division don't cancel. So, but a lot of students will try to do that, and that kills a puppy if you make that mistake. Okay, so we're not going to do that because we're not going to kill puppies. So we're going to go back to the steps. So we've got numerator over denominator, we've got descending order, and then what is the next step? Factored form. Okay, so I'm going to look for 2 things that multiply to -5 but add to -4. And 2 things that multiply to -15 and add to -2. Multiply to -5, add to -4. -5 and 1. Okay. And then multiply to -15, but add to -2. -5 and 3. Okay? And then from there, we can reduce the common factors. So what do you guys see? X minus 5 divided by x minus 5, that makes a 1, so we can cancel that out. Anything else?
Divide by 5 by x.
Can we cancel out the x's? That would kill a puppy, right? So no killing puppies. So we're going to say x plus 1 divided by x plus 3. So we can't cancel those x's because if we cancel those x's, we would be saying that addition and division are opposites of each other, and they're not. That's why we're going to not cancel those. Okay? So you can only cancel parentheses if the sets of parentheses are identical. If the parentheses are not identical, you cannot cancel them. Okay, so x plus 1, x plus 3, we are finished. Okay, everyone feel good about that? All right, take your notes, flip it back over to the front. An excluded value is a value that makes the expression undefined. An excluded value is a value that makes the expression undefined. Rational functions are undefined when the denominator equals 0. Can't have 0 on the bottom of a fraction. It doesn't work. Okay? So how do you find these excluded values? You take the bottom, you set it equal to 0. And that's how you find the excluded values, okay? So what we're going to do is, and you do the bottom equal to 0 at the beginning of the problem, not the end, okay? And it's usually easiest to do it in the factored form if it has a factored form. So when we look for the excluded value for this one, and it's actually, let's go ahead and switch colors. So if you have another color pen, this would be a good time to use that colored pen. Okay. So an excluded value is a value that makes the expression undefined, and rational functions are undefined when the denominator equals 0. Okay. So how do you find the excluded values for example 1? Excluded values. We're going to say 24x squared equals 0. And then if we want to solve for x, what do we do first? Divide by 24. What's 0 divided by 24? 0. So then we get x squared equals 0. And if I have x squared equals 0 and I want to solve for x, what do I do? Square root it. So x equals, and then whenever we square root something, we should always say plus or minus, right? Plus or minus that number. But in this case, we're square rooting 0. And what's the square root of 0? It's just 0. So saying plus or minus here doesn't change anything. So we're going to say x is 0. Now these are excluded values. Excluded values are numbers that you cannot have. You can't have them. You can't plug this in. So of all the numbers you are allowed to use, this is the one number you can't have. You can't have 0. You can use 1, you can use 2, you can use -5, you can use pi, you can use tau, you can use Euler's number, you can use Avogadro's number, you can use Pete's number if he had one. Alex has probably got a number.
I declare it to be 5.8.
There we go. Bets's mom might have a number we don't know about. Anybody can have a special number, and all those numbers are allowed to be plugged in so long as they aren't 0. Okay, so we're going to go back. It's an excluded value, so we put a slash through it. Equal, x cannot equal 0. That's how we show it's an excluded value. Okay, x cannot equal 0. In fact, if you want to show it's excluded, we could go through and put slashes through all these equal signs.
But it does work in simplification because it's 3 times 0.
But this is a simplification of this.
Right, but that, if you solve it the other way too, that's 0 over 0, which is
Ask Siri what 0 over 0 is.
not a number.
It's undefined. It's an indeterminate form that is undefined. Yeah. All right, let's try the next one.
Why is it valid in the factor? Why is it valid in the factor?
You'll learn this more in pre-calc. It's called a hole. It's still, if you were to graph it, it's still missing. It's a point that's not there. It's still excluded. It would be missing off the graph. Yeah. All right. Let's look at, and actually I can show you if we were to graph this.
That solution there isn't even quadratic.
Nope, it's a straight line, linear. Yep. And you'll see it when we graph it. You'll see it as linear, but it'll have points missing. So, hey guys, let me show you really quick. I just want to prove to you that if we look at this, 24x to the second, so our final answer is 3x over 4, which is the line, 3/4 x. So that is a slope of 3/4, a y-intercept of 0, okay? But if I go and I want to plug in 0, the value of 0, if I plug that in, it has no output. Everyone see that? It has no output because it's undefined. It would, if we go look at the table. If you try to plug in, if you try to plug in 0, it says error.
But if you can find the value using a simplification, then where does the value be?
You can do that, but it's a value that is not there. So your calculator is saying it's a value that's not there. A human being could do it. A calculator is going to say that value does not exist because the rules of math don't allow it to exist. Yeah. All right, and that is something you'll learn how to find those y coordinates, but they're a pre-calculus concept, not a math 3 concept, which is why we're not doing it right now. Yeah, it's the extension of this unit, but it's the pre-calc extension of this unit.
So
yeah.
I guess it could be either infinity 0 or negative infinity.
They could be actual numbers. Yeah. All right, let's do the next problem. So here, if we want to know what the excluded values are, we take the bottom, we say 3x times x minus 2. So we're going to write our excluded values. And we're going to set it equal to 0. And this one, because it's in factored form, the excluded values are a little bit easier to find. So we're going to have 2 of them. We're going to have an excluded value for this, and we're going to have an excluded value for this. So over here, this is going to remind you of factoring. So what's this excluded value? 2, x equals 2. And then what's this excluded value? 0. And now because these are 2 values that make the bottom equal 0, we just have to add it's excluded, it's excluded. X cannot equal 2, x cannot equal 0. And if we ever want to double check it, we can just graph that function. On the calculator, 7x times x minus 1 over 3x times x minus 2. And if we look at the table, we can see that 0, an input of 0 has an error, and an input of 2 has an error. Those are the 2 excluded values. Yep. Looks like a rational function. All right. Next one. So if you were to look at the denominators for your excluded values, we can look at this denominator and we can look at this denominator. They are both good denominators to look at because they are both denominators before we canceled anything out. Does that make sense? Now, if I'm looking at the denominator and I'm setting it equal to 0 and I want to see what the solutions are, I'm going to use the factored form because the factored form is easier to set equal to 0 and solve. Does that make sense? The factored form is a little bit easier. If I take this form, I'm just going to have to factor it and then solve it anyway. So for my excluded values, I'm going to say x plus 8 x plus 5 equals 0. And then what are my two excluded values? -8 and -5. X is -8, x is -5, and I cannot equal either one of those. Yes, they're excluded from the domain. You can plug in any number, you just can't plug in those because it makes the denominator 0. And you can't divide by 0. It's not allowed. Just ask Siri. She will tell you. She will tell you it doesn't work. All right, go ahead and flip the page over. I want you guys to try to figure out the excluded value for number 4. So we've got, here's all the denominators we can see before we canceled something out. Look at them and see which one you should look at to determine what the excluded values are. So these are all good. We don't want to look at this one because this is after we canceled something out. So don't look at this one. But all of these are before we canceled something out. So see if you can figure out, based on these, which one is most beneficial to find your excluded value. And is there only one excluded value? Are there 2 excluded values? Are there 3 excluded values? And can you tell what they are? So go ahead, look at the problem. If you feel comfortable after number 4, you can keep going.
I figured I had a calculator on my calculator.
Oh, good. Anyone want to share what their excluded values were for number 4? Yes, Alex.
-1, 0.
Okay, perfect. So we got x equals -1, x equals 0, and then because they're excluded values, we say cannot equal 0, cannot equal -1. Does that make sense, everybody? Okay, anyone get excluded values for number 5? Yeah, CJ, what'd you get? 4. So we just have the 1, x equals 4. How come this part did not give us an excluded value? Okay. Yeah, there's no x involved, so it's not going to be a solution for x because there is no x there. Okay. All right, how about the last one? Yeah. Okay. X equals 5. X equals -3. Perfect. All right, your brain's feeling pretty good about that stuff? Okay, so did you have a question, Alex?
If you enter the denominator into the if you enter the denominator in the equation and graph on your calculator, and then just find the root.
Uh-huh. Which is the same thing as solving it. You're just describing using the calculator to solve it. Yep, exactly right. Okay, so if you look at, this is what we're going to be doing next. So we're going to be simplifying for some of the problems, and then some of the problems ask you to simplify and state the excluded values. Okay? Answer key is on the back wall, so you can check your answers as you go if you would like to.